into 5. So we get tangent pi is equal to tangent theta IZZ over IYY. Okay. So this equation over here, this is our equation number 7. Okay. So this equation over here is to determine the orientation of the neutral axis from the z axis. Okay, it's from the z axis. So if we go back to the example that we did on Wednesday, which is this one, right? We did this example. I'll start on a new page. All right, we did this example. So over here, we knew that what we have determined IYY, which is equal to 64 inches to the power 4. And then we have IZZ is equal to 88 inches for 4. And we know that our theta is equal to positive 20 degrees. Why positive? Because from Z to here, it is positive 20 degrees. Okay, positive, because it's going in a what? Clockwise orientation. Okay. So to find our position, of the neutral axis, right? To find the position of the neutral axis, we simply apply the formula tangent pi is equal to tangent theta IZZ over IYY. Okay. So we know that 20 is going to be positive. So this will be equal to tangent 20. Okay. And then multiply by IYY. Sorry, IZZ, which is 88 over 64. And then from here, we can compute our pi. So tangent 20 times by 88 divided by 64. Inverse tangent is equal to 26.6 degrees. Positive 26.6 degrees. So what this means is from Z, okay, I highlight again, I repeat it. From Z, our position of our neutral axis is like this. Okay, I'm drawing 26.6 degrees. Okay. So this over here, this is 26.6, and this is the position of the neutral axis. Okay, I'm going to do another example from the textbook. Let me see Oh, I do apologize. I'm looking for another example from the textbook to do so that you will be clearer. Okay, let me see is another, which I don't need to find the second moment of area for sure. Bear with me, okay? Because you can get confused. I mean, I did get confused with the angle, and I don't want you to be confused with the angle. Let me see. Okay. I found one good example over here. Okay. Right. So this is example number 1. I do apologize. I did not post this. This is a spontaneous example. Okay. Right. So given that IY prime and IZ prime, I want you to focus on IY and IZ. The axis is in such an orientation that is orthogonal to the structure, right? And C is where the centroid now. So for this case, right, we know that what do we need? So we know that the formula is tangent pi is equal to tangent theta over IZZ IYY. Okay. And you realize that Y prime and Z prime is attached to the structure. Okay. So from here, we can see that Z prime, right, from Z prime, now this angle over here, this will be our theta. And we know that the theta now go anticlockwise. So therefore, theta is equal to minus 45 degrees. Why minus? Because it's going what? Anticlockwise from Z, right? So we know IZZ and IYY. So from here, we can immediately plug in the formula. Tangent pi is equal to tangent minus 45. Okay, bracket. IZZ is 21.4. And then divide by 6.74. Right? So pi is equal to tangent of minus 45 times by 21.4 divided by 6.74 inverse tangent. So it's equal to minus 72.5 degrees. Okay. So what does it mean by minus 72? Let me calculate again. So tangent minus 45 times by 21.4 divided 6.74 inverse tangent, right? Yeah, it's minus. So what does this mean? Okay, so now I'm going to sketch the position of our neutral axis now. Okay, now I'm going to sketch the position of neutral axis. So 72.5. Okay, so this is the position of our neutral axis. Let me write this down. So this is our position, or this line is our neutral axis. And the angle is from Z prime going in a anti-clockwise direction because it's negative, and this angle pi is equal to minus 72.5 degrees. Okay. I will draw another example to clarify things if you are confused. Okay, I'll use the same diagram, but this time I'm going to change. Okay. This time, okay, the applied moment is not in this direction anymore. So I'm going to cancel it. Okay, the applied moment is not in this direction, but rather the applied moment is like this now. Okay, so the direction flip. So now what we have over here now, right? So again, our theta now changes, right? So this is our theta now, right? So theta now becomes positive because it's going clockwise, positive 135 degrees. Okay. So now if we were to put in the formula, tangent pi is equal to tangent, now it's positive 135 multiplied by IZZ 21.4 divided by IYY 6.74, right? So from here, pi will become tangent 135 times by 21.4 divided 6.74, and then inverse tangent. So now it is again minus 72.5 degrees. All right. So the position of the neutral axis is still the same, but something changed. Okay. So I'm again going to sketch the position of our neutral axis. Okay. Again, it is at minus 72.4. Oh, sorry, 72.5. So this again is our position of our neutral axis. Right. This will be our position of our neutral axis. So again, because it's also minus over here, right? So this will be from here to here, right? So pi is equal to minus 72.5 degrees. Okay. So I want you to be very clear with this. The most important thing is clockwise is positive, anti-clockwise is what? Is negative. Okay. Right. So from here, we are going to go into a not necessary a new topic, but you guys have done it in 2P, but I'm still going to go through it again. Okay, before I go on, any questions so far? Okay, I don't hear anything. Okay. So the next topic I'm going to do, and it's one that's very important. Okay, so it's known as eccentric symmetrical bending. Okay. So I've posted these diagrams